Good evening, ladies and gents. This is week 2, FST 4310, Quality Assurance of Food Products. Today we'll be talking about quality specifications. So for this particular video's agenda, the first thing I'm going to do is recap quality assurance concepts, which was the live lecture that was presented on Tuesday. Then we will go into the lecture proper, quality specifications. I have some comments about how to apply this lesson to your project, and then I'll tell you a little bit about your assignment. Okay, a sort of a recap of what we covered last week, and actually earlier this week. So last week we talked about food industry professions. The focus was more on the company as a whole, specifically those who do not work in a food science capacity. Just getting to know what they do and try to sort of respect and appreciate their contribution to a company. Then I talked a little bit about certain quality concepts, but it was focused on what people in quality do in a food company. I talked a little bit about food safety versus food quality, how they're different and how they interact. I talked a little bit about something called total quality management, where everyone in the business is responsible for contributing to the quality of the products that are sold. A quality department will focus on it and make sure that whatever program is running, it's maintaining that quality. But the truth is, everyone from sales reps to managers to production workers to even the graphic designers who make the labels, they all contribute to the overall success of the product and meeting the expectations of the consumer. We'll now be talking about one way in which quality departments help the company meet those expectations. So, not all foods are created equal. Just take a look at your local grocery store. If you want to buy a certain type of product, there are several different brands with their unique characteristics. Or a soda, for instance, like in this picture here, you have Coca Cola and Pepsi. Those are both technically colas, but in a lot of ways they differ in terms of taste, they differ in terms of mouthfeel, the appearance of each is different, and there might even be a variety of different flavors. I think Pepsi just came out with a mango one. Both have cherry, but like Coke has more varieties of cherry, like cherry with vanilla. Crystal Pepsi, which is clear Pepsi, is actually available to buy in Pennsylvania. At least when I was there in Penn State. And then I think back in the 90s or 80s, you had New Coke, which was basically a modification of the old formula. But the point is, even for products that are otherwise identical in many ways, there could be individual characteristics that differ between them that ultimately distinguishes them from one another. As such, when you're working in the food industry, it's very important to understand precisely what products you're handling slash selling. If you're working in the purchasing field, you need to understand exactly what kind of ingredients you're buying and make sure that the ingredients actually match your needs. Just because it's flour doesn't mean it's the kind of flour you need, right? It might have some things about it that you don't like. Or more appropriately, don't meet the quality standards of the manufacturing side of it, the production. For companies that sell to restaurants and grocery stores, they're the business that want to make sure they end up with the right products to sell, the best quality foods there are out in the market, because, well, simply put, it's easier to sell a product that is popular or is just superior in quality. As such, it is very important for sales, purchasing, food scientists, really everybody who's involved in the handling of the food in some manner, to communicate effectively about different characteristics of the products or ingredients that they handle or sell. It needs to be in a systematic way with some technical reference points. It helps to have some sort of convention, like a product code number or something like that. Last but not least, it's just important to understand just exactly what the expectations are for your product or your ingredient. In essence, you have to define them somehow, and that is the purpose of quality product specifications. Product specifications are all the predefined or measured or what have you quality and safety characteristics, requirements, and guidelines for the product's use. So you can probably tell from that previous slide that it's pretty important to have quality specifications when dealing with food. But let's really get to the fundamental reasons why specifications help. First off, a company has to set standards of some kind, right? They really have to set certain minimum requirements for the ingredients they purchase and the products that they ultimately sell. You ever wonder when companies brag that they always buy the best ingredients or they use them for their food? Well, one way they can actually achieve that to some extent is through specifications. When they know the specifications for their raw materials or their ingredients, they know what to look for when they start shopping for suppliers. And better yet, when they need to look for a certain ingredient and there are hundreds of varieties on it, they can actually narrow down to a couple that satisfy their needs and eliminate the others from the searching process. I mean, think of it this way. Let's say something was missing from your car or your device, like your laptop or your phone, and you need a certain part of it replaced. Will any part do? Not necessarily, right? It's sort of the same thing with ingredients in manufacturing. You got to find the right components for the job to make sure that your product is exactly how you want it. If you want a food example, there's a chemical called trehalose. It's a disaccharide that does exist in the wild, mostly mushrooms and shrimp and some whatnot in small quantities, but the food industry mostly produces it from cornstarch. The food industry loves it because it lowers the freezing points of some foods, and it can bind to water and retain moisture. And on top of that, it just isn't as sweet as powdered sugar. Anyway, my point being, we had some customers from beverage and baking companies ask for it. We carried it for sure, but it's not a guarantee that our product is exactly what meets their needs. The powder we had was kind of coarse. Maybe they need something very fine, so it dissolves faster in water. The version of trehalose that we carried, it was not organic, but some of our customers may want that. Then even on the flip side, as a consumer, would you buy a product that you don't trust or you don't know what's in it? Or would you ever buy a product again if it turns out it didn't quite meet your own standards for what that product should be? Say you bought a certain brand of laptop or phone, and you just weren't happy with that brand, like it broke down on you all the time, or it just wasn't reliable, or was slow, had a short battery life. Did it annoy you when the device you bought didn't have some features you wanted? And then just to add insult to injury, had a lot of apps that you didn't want, or features that you just didn't want or never used on there. Well, those are specifications that didn't meet your needs. And you know what? No matter how complex it was getting from the computer being made to ending up on your store for you to look at and consider buying, that's definitely one way of thinking of why specifications are so important. The only other thing I would say is that it's normal for both manufacturer and supplier to have their own sets of specifications. So there's a lot of comparing and contrasting to do. Now, in determining the specifications for a product, you want to consider all the different ways and methods that a product can be described or measured. When you want to characterize a certain thing about a food, there is a subjective way and an objective way to do it. Or rather, several different subjective methods and several different objective methods. For subjective specifications, you can think of them as just being in the eye of the beholder. If you and a friend look at the same dish that you guys eat for dinner, your friend might think that thing looks disgusting, but you think it looks delicious. For a specification that's objective, you try to base it on a physical property or something that can be observed or measured in a way that doesn't involve a person's opinion or senses. Going back to the example of the dish, and admittedly this is kind of a silly example, but I think it'll work for illustrating this definition. Let's say that the two of you decide that when a dish looks good, it's because of the presentation. The two of you decide that a dish must have at least 2 flowers on it for it to look good. The two of you look at the dish again that you guys haven't looked at for dinner, and you notice that the chef actually put 2 flowers on there. Therefore, the two of you objectively agree that the dish looks good. Next, there is also a qualitative and a quantitative way to describe a product. I will give you a more serious distinction here. I trust that most of you have taken food microbiology. If so, then you've been subjected to a bunch of different tests, which are either qualitative or quantitative. Doing the labs where you had to count the number of bacteria on a plate after incubation, that's a quantitative method. If you did a gram staining of bacteria to see whether or not it was gram positive or gram negative, that's a qualitative test. In the case of the quantitative test example, that's for counting how much bacteria is in something, so the level of contamination. And then for the qualitative test, it's used to classify the bacteria in terms of the type. You've probably picked up that in both those examples I gave for the qualitative and quantitative tests that both happen to be objective methods, neither of which truly rely on a person's opinion or sensory capabilities. Sure, the person must be able to see, but if a gram stain result is purple, then it's purple, meaning a gram-positive test. There's no arguing about whether this particular purple is less purple than the other. It either stays purple or turns red when it's gram-negative, end of story. So in defining a specification, in order to properly classify it and the method used to try to either describe or measure it, you have to take both of these factors into account. Heck, I'll even throw in another example. If you want to test the viscosity of a syrup, you can either stir it with a spatula to make it subjective and qualitative, or you can make it objective and quantitative by using a viscometer. You follow a certain protocol You adjust it to certain speeds, and you try to measure the viscosity by recording the data of shear stress versus shear strain. And then, at least for a Newtonian fluid, you can just measure the slope to get the viscosity. My favorite example for a subjective yet quantitative test is a customer survey. On a scale of 1 to 10, how much do you like your experience at McDonald's? How much do you enjoy eating hamburgers? One sort of question I've thrown on before on a test or quiz is a true or false question about whether or not sensory panels were objective and quantitative. Well, technically, no matter how standardized it is, and trust me, there's some that are very, very standardized, and they all make claims on being as objective as possible, well, they're still using human subjects, right? And they still have different sensory capabilities between each, and they'll always have different opinions. Even with the best trained sensory panelists, when there's something that's harder to describe, there are going to be some discrepancies. If you ever had a COVID test, that's a qualitative yet objective method for testing whether or not you have been affected. Speaking of which, stay safe. So we're looking at this slide. I've already touched upon subjective versus objective, but let's go through some more examples. So the olfactometer is one that I'd like to discuss a lot because it's kind of hard to really pinpoint whether or not it's truly a subjective versus objective. I'm of the opinion that it's still a very subjective method, but there have been arguments made that it's about as objective as you can get when it comes to measuring smell, or I suppose aroma of a product. If you're not familiar with the instrument or the technique, an olfactometer, and the instrument technique is called olfactometry, measures odor by sending a fixed amount of a certain odor through air. Basically, it's flowing controlled air that's carrying a certain odor that's of interest to whoever's doing the study. And what happens during an olfactometry experiment is that they have a test subject stand in front of the device and just try to see if they can smell something at different levels of concentration of that odor. Now, because the level of concentration of that odor can be controlled, you can easily determine the amount of odor that's in there by number, by the concentration. So in that sense, it is a quantitative method. The subjective and objective is where it gets a little bit blurry. I'd argue that it's a subjective method because it depends on the ability of the subject to smell something. In fact, when learning how an olfactometer worked, the first thing I was exposed to was essentially a study of determining what percentage of test subjects can detect an odor at a certain concentration, and then just plotting that percentage versus the concentration. At the same time, scientists who rely on olfactometry try to get around the limitations of human senses by having their test subjects exclusively be trained individuals who are specifically prepared for such experiments, and thus pretty much are used as the frame of reference. And then what they would do is, using that test subject, they would characterize a particular food as being spoiled, or being acceptable, or being especially aromatic, or what have you, whatever question it may be, based on the concentration that subject can detect of that particular odor. So say a carbonated water company like Bubbly or Perrier or Polar wants to make their new drink smell like banana. Using the various aromatic compounds that they have on hand to possibly create that banana flavor, they will probably identify the key compounds contributing to that flavor and have their test subject smell them at different concentrations to determine which amounts are perfect for recreating that banana scent. So I guess for the purposes of your tests and quizzes, if I ever ask a question like this, pay attention to how I present the problem. How exactly is that olfactometer being used? The other example on here is a lot more straightforward. A texture analyzer is just an instrument literally designed basically to simulate a human bite. So a person would put a sample onto the instrument and then press a button, and the machine basically comes down on it hard twice. And the data recorded is basically the level of compression to the sample or stretching compared to the amount of force applied. It's not the most scientific way, perhaps, to characterize texture, but it is very much still a quantitative and objective test. Now, looking at this slide, we've already talked about the qualitative versus quantitative and what distinguishes between them. And actually, even on the bottom point there, we've already talked about the fact that some methods can be used both for quantitative and qualitative tests. So I'll just toss in one more example here. Starch iodine testing. Most people use starch iodine testing qualitatively. So basically the question is there starch in there, yes or no? You just put whatever that thing of interest is in a solution. You mix it in water if you have to, or maybe it's already a liquid. And then you just add a little bit of the iodine complex to it and see if it changes color. If your mixture turns black and blue, well, you've got starch in there. Want to turn it quantitative and measure how much starch is in there? Treat it like a titration, similar to what you guys did in freshman level chemistry for testing the pH. GC, gas chromatography, and HPLC, high performance liquid chromatography. Those are very popular for identifying certain compounds in a mixture, but with some sort of standard reference curve. Comparing the concentration to the signal you get from the instrument, you can actually estimate how much of a particular compound is in there, and suddenly make it quantitative. So I could go on and on and on with these. Honestly, I expect you to know some very basic lab methods and what they do. Just go through the ones you remember from your courses and just think of it through this metric and see what you come up with. That would be good practice for understanding this concept. Okay, so quantitative specifications. Their benefit is quite clear because you actually give a descriptor for a food an actual number that you can work with, or maybe a number range. So, for instance, in describing the sweetness of something, you can measure that in terms of Brix. That's basically a measurement of sugar in a certain solution by mass. 1 Brix is basically 1% sugar by mass. If you want to describe the appearance of something, most ways of describing color are subjective. But if you've ever used one of those like colorimeters, like a Hunter LAB or a CIE LAB, it's basically those instruments where you take something that kind of looks like a camera, you put it down directly on top of the food, and you press a button as if you're taking a picture. Well, that thing was designed in the first place to give color some sort of quantitative form of measurement. And aside from having a number that you can actually work with, there are other advantages to quantitative specifications. The main advantage for quantitative specification is that it can be used to ensure consistency in production. You might want to use the minimum quantity acceptable for that specification as a lower control limit, and you want to use the maximum tolerable as an upper control limit. And obviously there's an average in between. The most common application for this is weight, and it's used in a technique called statistical process control. There's naturally always going to be some variation in a product when it's being made, and that variation could affect the overall quality of the product. This is what a SPC, statistical process control, quality chart looks like. Basically what happens is a quality control tech enters the production floor while production is going on, and then at regular intervals the quality control technician will take a couple units off the line, measure it for whatever quality they're looking for. In this case, again, we're worried about weight, to make sure that the quality of the product is being adequately maintained at all times. So what's typically done, and it really varies between companies, but this is just sort of the simplified version. The average of whatever specification they're worried about, what's considered acceptable, is the target weight. And the upper and lower control limits are based on calculations derived from the estimated standard deviation of whatever specification is being measured among the samples. Now, I'm not getting into the nitty-gritty because I've never done this calculation myself. What I will say, however, is that it's not just the mean and the standard deviation always. There's all these sort of things to consider. Requires the background statistics to know. If you have that background, one of the recommended textbooks that I gave out in the beginning of the course that can help you explore this topic more. But what you do need to know for entering quality control and quality assurance work is that basically at certain times a day, you need to take measurements of whatever it is that is being measured, and then you want to map out those averages along a certain chart according to the time of day. And so you can get an idea of how that process is being controlled during different production days, different production cycles, to get some insight in how the process is being controlled over time. The main textbook does too, but to be honest, I don't really follow their explanation. Anyway, that covers what I wanted to talk about as far as the technical aspects of specifications go. Let's talk more about the specifications themselves. One of the first things you can describe about the product in terms of its specifications is its appearance. The most common application for this is identifying what makes an ingredient good for use. So, for example, rice would be a very important raw ingredient for a lot of manufacturing processes. When checking each shipment of rice before using it in production, people will check for the level of contamination inside it. People don't want bugs, people don't want dirt, people don't want rocks in their rice. Produce as well, so most agricultural products that you see sold as fresh fruit, they have to be a certain size or shape to be considered worthy of that grade for sale. Otherwise, they're just used for things like canning, or worse, they're thrown away because the consumer expects it to appear a certain way. One more obscure example I can pull from work experience is the thickness of noodles. You could measure it in terms of millimeters, the thickness of a noodle, but the industry uses something called a slitter number. This is because machines are used to cut a lot of noodles most of the time for most factories. Doing by hand is mostly like a restaurant delicacy sort of thing, really. The slitter number refers to the size of the cutter being used to cut the noodles. And so, at my first job at the Japanese company, we had several different types of noodles, and the slitter number was actually indicated in the description of the product, the name. If you're curious to learn more, I'll throw in a link in the description later. So anyway, the take-home point I want to make here is that the appearance does describe the product itself in terms of like its color, its size, and whatnot. And as far as determining whether or not a product was made correctly, that can be good enough. But it's actually even more important describing some of the other characteristics of it. So like again, for an ingredient, whether or not it's even acceptable use, like how would you know it's spoiled or not? At least as far as your eyes can tell. You can even describe the contents, like say of a soup. Make sure it has like certain chunks and stuff whatnot in there. That can be an indicator whether or not it was made properly or not. Like imagine a chili with beans product that's missing its beans. It may sound obvious to you, but it actually has to be written down on some sort of document saying like, hey, this product is supposed to have beans in there, so on and so forth. Next, let's talk about the aroma, or as I have been referring to it earlier, the smell of the product. Yes, you can use a sensory profile to describe a smell of a finished product, but there's a practical use for the aroma as well. The smell is actually the quickest way to determine whether or not raw meat is acceptable for use. Meat that's old and rotten, even when frozen, smells really, really bad. I can tell you from experience. I've had the displeasure of smelling rotten rabbit before at work, and I'm sure those of you who are meat eaters, if you buy meat from the grocery store, it's uncooked, and you leave it in the fridge for several days, well, that's not going to last. It's going to turn slimy and weird, and it's going to have this really strong, musty aroma with it. What's it compared to? I think it's kind of like a mixture of like rotten eggs and like mud. But yes, basically, when someone describes the aroma of a raw meat that's to be used for production, the specification might say that that particular meat smells exactly how that meat should smell. What I mean by that is, let's say you received a shipment of raw beef. The specification would say, oh, the aroma would have the typical smell of beef. No off odors or putridness. Sounds pretty vague, right? But at that stage of production, you're not trying to be an aficionado of raw meats. You just want to make sure that meat smells okay to use. The more descriptive, vivid, and sort of imaginative adjectives for describing the smell of a product really come later when the finished product is being described. So maybe you bought, let's say for that beef, you bought steaks, right? And then you're making a pre-made steak dinner. Well, then the specification for the final product should contain a more vivid description of the steak. So, like, say the steak was seasoned a certain way, you wanted to smell spicy, you wanted to smell, earthy, grassy. Maybe you cooked it with bacon, so you want to have it give like a hint of a porky smell to it. Not too much. Really, that's up to you, but that's where you get more creative. All right, the flavor. This is another good one that you want to describe. So that's simply the taste of the food. This specification is much more useful for the final stages of the product. As you can imagine, it's not exactly safe to say, taste raw chicken before you start using it. Though for raw materials that are safe to eat, like cocoa nibs or coffee powder or certain spices, maybe certain nuts, the flavor may be a factor. Or, as I put in here, any raw fruit or vegetable might have a flavor specification as well. You want to be careful here, though. It's not just how any product of this tastes. You're trying to describe how the best version of the product that you're working on tastes. Say you know how to make a certain soup, and maybe you made that soup like 50 to 100 times in your life so far. What sort of tastes can you describe when that soup was especially good? And what sort of tastes can you describe when that soup was not as good as when you made it other times? Well, if you were to create a specification of flavor for your soup, you'd probably want to describe it more like when it was good. Carrying that analogy over to, say, working for a food company, you want to make sure that the food you're producing is tasting exactly how the customer expects it to. So, at least in the eyes of the consumer, what tastes best to them. As you can imagine, describing the overall flavor is oftentimes a subjective experience, but there are ways to make certain aspects of it, like the sweetness, objective, or at least measured objectively. Texture is a very important part of the eating experience. It might be a good time to describe the firmness of the product upon biting it. Perhaps you want to describe the mouthfeel. Is it viscous, and if so, how viscous? And is it soft or hard? This is actually a specification that even a lot of beverages have to consider. Some of them because they're thick enough that they might qualify as foods, like some milkshakes, or some yogurt drinks. Those are rather thick. They can almost be treated as soup in terms of their consistency. Um, Carbonated beverages, they have to worry about what the level of carbonation does and how that affects the sort of perceived mouthfeel of the product. I think they might call that smoothness. You hear that a lot when talking about beer, for sure. The viscosity can also play a role in the texture. Certain syrups are certainly easier to swallow than others, and the ones that are very, very viscous and very, very thick, boy, are they hard to swallow. But that would be something that could be on a particular product specification, and maybe certain customers want it extra thick. Who knows? But that's something that has to be defined and measured. Next, we have the expiration date. This might be tied to the food's shelf life, or the length of time for which an item remains usable and fit for consumption or saleable. You're probably aware that the expiration date on most foods is not necessarily a safety metric, but one more of quality. So if you ate a prepackaged product that was past its expiration date, you may not necessarily get sick from it, but it might not taste as good. Defining how the expiration date is labeled on a product is still very important because businesses, customers, and consumers will just not accept products that are older than their predetermined shelf life, like have gone past that date, or have been older than what's promised. So you could try selling expired product to a business partner, but you can better believe they're going to return it and not be happy about it. And that's why this specification exists. For a lot of products, this is just a uh, calendar date, so like the month, the day, and the year. But some companies have their own production codes. The beer industry is notorious for this. I don't remember their exact breakdown, but basically, it's rather than just have a normal month, day, and year, they have like an 8-digit letter code plus some numbers that correspond to like what plant it came from, like which brewery actually made the beer, the month that it was actually brewed and bottled, the year that it was bottled. That's all hidden behind some sort of cryptic code that has to be sort of cracked by someone who's an expert. There are blogs and websites and whatnot that teach you this sort of thing, though. Although it's far from the best way to track products, some companies do track the batches that they made based on their expiration or production dates. So that's something to keep in mind too. Next, obviously, anyone who buys a particular food wants to know what's in it. So you need to have some sort of ingredients list on there or ingredients statement. For materials used in manufacturing, the raw material, so to speak, most of the time it will not have an ingredients list unless that ingredient itself is processed. So, for instance, raw meat is just that raw meat. So there's really no need for an ingredient statement on there. It's obviously whatever animal that came from. But for something like, say, table salt, sodium chloride is not the only ingredient on there. At least as far as like non-kosher salt is concerned. For a lot of cheaper salts, they might add certain anti-caking agents. The salt also might be fortified with potassium iodide. Maybe your company's making barbecue sauces and you guys use ketchup manufactured by another company, so you want to know the ingredient breakdown for that. Whatever the case, it's the responsibility of the manufacturer to keep records on what exactly went into the product, including the contents even of the processed products that went into it as well. And so you'll see that in every specification sheet. If there are multiple ingredients used for a product, there better be an ingredient statement on there. More on that when I talk about label laws next week. The weight's a very important specification, and we'll be talking about that in more detail actually at two different points. The first of these, I think, is next week when I talk about labeling laws. And then the second time I mention it will be when I discuss how to do certain things in Excel with respect to inventory management. So that's something to look forward to. For now, what you need to know is that the weight's important to be listed on a product for a couple reasons. First, it's illegal to knowingly sell anything that's under its stated weight. That's considered a violation of a federal law. And when done intentionally, it's widely considered to be a fraudulent business practice. A heavier product requires more energy to heat it to the right temperature. The buyer definitely wants to know how much a certain thing weighs. And of course, the weight can affect the way that the product is packed, stored, and transported throughout the food industry. So that's something to consider too. In the U.S., metrics are used, but most of the time when communicating with other businesses, the net weight is measured in the imperial units, in ounces and pounds. And you'll see the weight on the front of a package, or just somewhere on the outer label, and that label is showing you the weight for just the contents without the box or package being considered, and that's called the net weight. When you add the weight of the contents to the weight of the container together, that's called the gross weight. Storage instructions. So once I receive your ingredient, where should I put it? For most non-perishable goods, it's usually good enough to put it in a cool, dry, and dark place outside a refrigerator or freezer. Otherwise, for something that is perishable, like meat, may be best to have that restored in what I mentioned, a fridge or freezer. The temperature of the storage may be specified in some cases. It really depends on the product. Raw seafood would definitely have a specification on there somewhere stating that it needs to be stored in a frozen temperatures to stay safe and meet that shelf life that's been promised. Canned products can be stored in a cool, dry place. They're said to be shelf stable, meaning that they'll keep just fine outside of a refrigerator or freezer. It's actually pretty important because depending on the stage of production, it may make sense to store it at an even colder temperature than you normally would in a freezer, so that keeps longer. So actually, for most of our products that can be safely stored in a refrigerator, we keep that actually close to freezing temperature, even though it says it can be stored safely above that, just to avoid deterioration quality. And then for frozen products, we actually keep that at freezers close to 0 degrees Fahrenheit. 0 F, that's right. Same purpose, just to make sure that it keeps for several years if needed. Handling instructions. So how do I use it? Like, what do I do with this ingredient? Or, how do I even prepare this product that's been sold to me? In the context of manufacturing, handling instructions are basically what you do with raw materials and how to handle them safely for production. This information is especially useful for equipment operators because they have to handle large quantities of the product. So it's important to make sure they understand how to handle it safely and how to handle it in a way that makes sense for their production operations. If it's an oil, a vinegar, or some kind of powder, it might come with a chemical safety data sheet or an MSDS, a material safety data sheet. Those of you who've worked in a chemistry laboratory before, that should be familiar to you guys. For a real example, one of the jobs I worked alongside a production operator who was operating a mixer, just to get to know the product better. There was a lot of oil involved, huge tanks of it, easily 16 to 20 gallons per batch of whatever we were making. A lot of different vegetables and powders and even alcohol had to be balanced alongside that. So any sort of precautions on those specifications would really come in handy because those production operators have to juggle multiple things at once. On the other side of it, when you're trying to have a sales representative convince a restaurant to buy it instead of another manufacturer or a distributor, you may want to give some sort of instructions for how to use that ingredient, sort of like a serving suggestion, really. I did quite a bit of that at my first job, actually, because I used a lot of ingredients that came uniquely from Japan. And so a general audience may not be familiar with exactly how to use a certain ingredient that they don't recognize. It could also be a good opportunity to write instructions for a certain product, like how to heat it properly in the microwave if it's an instant product, whether or not you need to add hot water and let it stand for, say, a ramen product, so on and so forth. Some of these companies that have these handling instructions may also call them the intended use or the applications for the product as a specification term. So after all that is said and done, and there's actually a lot more, but that's just, enough for your assignment really. You want to define all these specifications, have them written down, and have them documented somewhere. And that's the purpose of a product specification sheet. This is ultimately what is exchanged between buyer and seller in terms of the information that is exchanged between them. Those documents will have everything that we've talked about before, but it'll also have the ID number of the product according to the seller's system. It'll have the name of the product, of course. It might have where the item comes from. It might have a picture of the product as well. But the point is, it has all the information that the buyer is looking for. uh, to try to help the buyer determine whether or not that ingredient actually meets their needs. That's really the purpose of it. If you want to see an example, I actually have one here. The one you're going to see on the next slide is from Heinz. It's a hot sauce, their Pete brand. So I can just take a look at it with you guys right now. So yeah, this is Heinz's product specification sheet for their Pete brand hot sauce. It has some of the stuff that we talked about. We have things like the product description, so that's the name of the product. You have the weight, and it looks like it's for the label. That's basically the weight that should be displayed on the case of the product. We'll talk about the packaging size and the UPC at a later date. You can see a description. So usually the description is the name of the product in most contexts, but in this case, they actually do sort of summarize what the product is. Some of the specs they include here are the location of the production site of where this hot sauce is produced. Um, some of the things like the analytical data, microbiological data. So that's just the different specifications for the lab tests that they do. They have container and case coding, which is very useful for tracking information. So they're using more than just the expiration date. You can see the storage instructions on the bottom. So that's basically where to store it. The shelf life as well. Um, some things that we talked about on the right here as well. So you have the ingredient statement that you can see on the right side. They were even nice enough to include nutrition facts as they appear on the label, as well as a per 100 gram nutritional analysis, which is very useful for calculating other people's formulations when they want to use this hot sauce as an ingredient. I find it a little odd that they didn't include any sort of flavor or aroma or texture specifications on there. That's pretty standard for most product specifications. I guess they decided to exclude that for some reason. Keep in mind, I only stuck to the specifications useful for your assignment this week. But what's actually included in the specifications really at the description of the selling company, really. So just to reiterate what I've said about specifications, this is by no means exhaustive. I mean, just from that spec sheet alone, you probably noticed that microbiological tests or indicators for contamination are a thing, such as an analysis for the microbials. Um, you often want to have a nutritional breakdown like they did at the end there. That's another one that's often added to some but not all specifications. Um, whether or not something is certified a certain way can be considered a specification too in its own right. And then I already talked about material safety data sheets. Vinegar is a very good example. Chemical salts. Um, Sometimes even salt would even have a MSDS data sheet for some companies that sell it. So that's just another thing to consider. For some raw materials, they may have a complete chemical breakdown somewhere. Um, I've seen a couple oil specification sheets actually with a complete fatty acid breakdown, um, down to the 0.1% actually. So yeah, this lecture wasn't meant to be an all-inclusive description of every specification out there. That's just to introduce you to the basics and give you just enough to work on your assignment. As far as recommended readings go, I'm planning to add some scientific tests to the YouTube channel for week two. Week two already has some videos on different descriptions for products. If you pay attention to how experts talk about like what makes a good chocolate, what makes a good wine or whatever. I'm actually kind of blanking out right now what kind of things I added on there. Besides that, I did promise the noodle link earlier in this lecture, so I'll add that to the description when I have it. When I have the opportunity. Um, Specification sheets. If you need to see some examples, you have the one from this lecture, but you also can see some on Canvas. It's in the recommended reading section for week two. Um, if you want to learn more about statistical process control, like I said, the we have a book dedicated to that as recommended readings. So if you want to find that somewhere, you can. Um, I actually have a video about statistical process control on YouTube, though that may require some background statistics to really understand. There are also some handouts that I might have found that I've added to the Canvas page. Um, I don't know if that's the case this year. I typically do that every year for this assignment. Sorry, for this lecture. Just check it out. Let me know if anything's missing. I'll try to look for something good related to this. The YouTube channel should have enough though. If you're just curious about how to describe certain products, get some inspiration. Now, before I get into your assignment, I realize I don't have a slide for the presentation or the final project, so I'll just add some comments here. You'll probably notice in the rubric, but if you didn't, for your final project, you're required to have a product specification sheet for one of your raw ingredients, and then a specification sheet for your final product. The reason for one of each will become extra clear when we get to week 4 and I start talking about supplier approval programs. As for your next assignment, consider any food that you might have in your house, or that you just bought from a shopping trip, or that you're about to eat from, say, delivery from DoorDash. Just take a look at it. Although for best results for this assignment, I recommend that you use something prepackaged for this. I want you to create a product specification sheet for this product. So whatever it is you choose, give it a look, give it a taste. Start creating a list of specifications for what make this product good and what you expect in a non-defective batch of this. So like if it doesn't go bad, what should it taste like? What should it smell like? What should it look like? So on and so forth. Along with the weight, and you can estimate if you have something that's not labeled. You don't have to be precise, just give a believable number. Um, then when you're done with that product specification sheet, you can just upload that to Canvas the same way you did for your first assignment. Now, for the product specification sheet, you can come up with your own, but if you need it, a template for you is available on Canvas as well. It'll be in Labs week 2. There should be a template for you there. All right, so if you have any questions or concerns, just leave it for me in the comments, in the chat, or just email me, or reach out to me in the Cal State LA Messenger. With that, I will see you around. Good luck.